Now let's talk a little bit about working with numbers and doing some basic math for numbers that we can store inside of variables. We'll start with just the math. So let's go down here and let's keep just one of our println's. And instead of this, we'll say print 2 plus 2 like this. We run this, you'll see we'll get 4. It's able to infer that 2 plus 2 is 4 and then print that. We can also say print 2 minus 2 like this, so plus minus. Of course, multiplication and division work the same way. If you're new to coding, multiplication happens with the asterisk symbol like this. 2 times 2 will give us 4, or just for clarity, 2 times 3, let's do that, will give us 6. Yep. And then if we want to do division, let's say 9 divided by 3 like this will give us 3. 9 divided by 3 is 3, and we can print that. Now let's talk about putting some of these math operations in variables, kind of combining skills, if you will. So let's create a num1 variable, and we're going to set that equal to 2 plus 3. And 2 plus 3 is 5, which will get stored inside of num1. And here we can print num1. And 5 should be the output. So we run this, we get 5. Now this infers that this is a integer based on what's on the right hand side. Don't let this fool you. It doesn't infer it's an integer based on what we called it. For example, if we say num1 equals hello, then it will infer that num1 is a string, and it'll still print it. But this is a case where we didn't declare our variable name very well. One thing you want to do when you're coding is write good variable names. So for example, num1 to store the string hello doesn't really make sense, but maybe greet or greeting is a better variable name to store string hello. In our case, num1 is going to store 2 plus 3 like we just had. We run it, we get 5. Of course, we can store any number of things. So num2, for example, equals 2 times 3, which will give us 6. And we have to print num2 if we want to see it, right? If we run it like this, we'll just get num1. Okay, num2 declared and not used. So we can't declare it without using it. It's specifically in this goplay.tools. I'm not sure about in your VS Code. You have to check that out. But we've declared this, but we haven't used it, so we have to use it somewhere. And I think that might just be a Go thing in general, which is good. So you're not having dead code just sitting around. So the editor was smart enough to know that we declared this variable, but we didn't do anything with it down here, so we need to print it. Now we run it. We get 5 for num1 and 6 for num2. Now let's talk about an interesting phenomenon here with floats and ints, and why sometimes it might be better to write the longhand to declare a type, so other developers and yourself don't get confused when you come back and look at the code. So let's get rid of num2 for now. Let's just talk about num1, and let's say num1 equals 1 divided by 3. 1 divided by 3 should be 0.3333333, etc. If we run this, you're going to see we get 0. Now, why do we get 0? We're inferring the type here into num1. 1 is an integer, 3 is an integer, so when it divides, it does a integer output, and it can't be a decimal, so I believe it rounded it or something like that. So if you want it to be a float output or decimal, we need to say like 1 divided by 3.0. So this is a float, this is an int, but it's going to coerce that whole thing to a float, and in this case, if we run it, you'll see we get this 0.33333. For another way, for example, we can change the first number, still float int. We should get a float as the output. If we run it, yeah, you'll see we get the same output. Oh, it's still loading, my fault. You'll see we still get the same output. Now let's suppose we want to make the result in a float. So in this case, we would say num1, we would have to say var num1 float 64, And I don't think this will work. I think this is going to error because int divided by int should give us int, but maybe it'll be able to say, okay, it wants a float. No, we get 0. Okay, that's interesting. So what if I wrap this in float 64? So I'm explicitly saying, hey, make the result of this a float and then give it to num1. We still get 0. Interesting. All right, what if we just do num1 colon equals? Still interesting. 1 divided by 3. Let's wrap 1 in a float like this. Now we get 0.3333. So that's interesting. So we can't wrap an entire thing of division in a float, something I just learned. So we can't wrap the whole thing and say, hey, we want it to be a float. But what we can do is wrap one of the numbers and say, yes, I want this one thing to be a float. So this int will be coerced to a float and your result will be a float. So now if I do this on the other side, var num1, if I try and say something like int, I'm probably going to get an error. Yeah, because I'm trying to make this a float, which would make the answer a float, but we have an int type here. So got a little deep into the types, but just wanted to show you that and learn something myself, which is kind of cool. The other thing I wanted to get into is a math library. So let's get rid of all this stuff. And we're just going to set num1 equal to 4 for now. We want to import the math library from Go. So to do that, if we want to import one thing, we can just use quotes. Like format is the format library. There's a bunch of code in there. We want to import the math library too. So we need to use these parentheses around this to import multiple things. No commas, just fmt, and then we want to import the math library. Not sure if it has to be capital F. I don't think it does. And we want to talk about two specific things within this math library for right now. There's lots of different things in here, but for example, let's say I can say math dot, math dot, and then hopefully it'll give me some options. Yeah, if I type in the word p, you can see I get pi and pow, and you can pick a letter and it'll give you different options. So here I get absolute value, cosine. These are all things that are built into the math package that we are importing up top here. So just like format has println, printf, print, it has a lot of other things too that we can use. The math package has these different items that we can use as well. So if I do C, nope, nothing in C, I guess. Oh yeah, there we go, seal. So rounding up, I wonder if it has floor rounding down. Yep, so floor is there. It's kind of underneath, but it's there. So if I do this, dot F, there you can see floor. So floor is like rounding a number down a float to the nearest integer. Another one might be round. Yeah, round is there, remainder, round to even. There's all kinds of options. We're going to be focused on pi and pow. So if I say math1.pi, like that, so we store pi inside of the first number and then we print it. Let's run it. And you can see math.pi gives us pi to as many precision points as I think are available. And we store it inside of num1 and then we print it. So again, math.pi is just a variable declared in the math package that we've imported. Another thing we can do is math has some functions on it, and we can, just like we feed something to our print function to be able to print to the console, we can feed something to our math.pow function like this. And you can see it takes an x and a y value, so a base and an exponent. X is the base, y is the exponent. So this is kind of a built-in thing. We can write our own power function, which could do the same thing, and maybe we'll do that down the line here, but for now we'll use the built-in math already imported power function that Go has in its standard library. So we can say, let's say 3 to the third power. So 3 times 3 is 9, times 3 is 27. So we should get math.pow 3, 3. So this is a way to pass two arguments in, just like println. I could print this answer and I could print something else, and I'll show you that in a second. But if there's more than one argument that has to go inside of one of these built-in functions like println or math.pow, we have to use a comma. So 3, 3. base exponent. 3 to the third power should be 27. Let's run it. We get 27. 3 to the fourth power, 27 times 3. So 3 times 3 is 9, times 3 is 27. I think times 3 is 81. Let's run it. Yeah, 81. So this is the base, this was the exponent, and you can see that works. Now let's suppose we want to label this a little bit. Instead of just printing the number, we want to say our answer is, and then the number. So to do that, we can, inside of print, just like we did above here with multiple arguments here, I could say something like, I could just put a string in here like this, my answer is, colon space, and so everything inside of those double quotes are just a string. I add a comma, and then I pass it the num1. So same deal as up here. I now have two arguments here. We should get my answer is, and then num1. Let's run it. My answer is 81, and it looks like I don't need this extra space here. Run it again. That looks better. My answer is 81. Now, of course, we can store this in a string itself if we want. So we could say answer string colon equals my answer is, and then instead of writing my answer is down here, we could just say answer, if I can spell answer today, answer string comma num1. So answer string is this, it'll print this, and then it'll print num1 here. And notice it's inside of println. Why isn't it printing these on separate lines? It's because we're passing both arguments or both values into one println, so the ln comes after both. In this case, if we wanted these on separate lines, we would have to fmt.println on separate lines. So let's run it. You can see we still get the same output.